We're Team Sushi Umke, and we made our visualizations from sushi datasets. Our dataset has information on the price of 100 different sushi types, their oiliness, how frequent it's eaten, and how often it appears in shops. We also have information on the demographics of the respondents for their surveys, such as which prefectures of Japan they're from and their age. Our audience includes people looking to eat sushi and people considering their budget, like some tourists. The audience also includes people wanting to learn more about sushi and sushi chefs and restaurant owners wanting to do customer research. One goal of our visualization is to help people discover the different types of sushi and what categories of sushi there are, which is accomplished through a circle packing visualization. Another goal is to allow the user to learn which sushis are the most or least expensive, for example, which is achieved through a bar chart and a sorting function. And a third goal is allowing the user to discover what kinds of people eat these types of sushi through a heat map of Japan.
In order to compare these attributes of the sushi, we created a visualization that utilizes a bar chart, a scatter plot, and a box plot. Our first research question was, what are the most and least expensive sushis? In order to determine this, our visualization allows you to select price as the variable of comparison and then sort the various sushis by value. As you can see, the most expensive sushi is Toro, and the least expensive is Sarada Maki. Does frequency eaten correlate with frequency sold in shops? In order to determine this, we developed a scatter plot. For the y-axis, we would select one of the parameters, in this case, frequency sold in shops. In the x-axis, we would choose another parameter. As we can see, there is a direct correlation. Our next question was, which sushis are in the upper 25% in terms of price? In order to determine this, we would set one of the axes of the scatter plot to price and then turn on the box plot setting. Using the box plot, we can determine everything within the upper quarter field is in the upper 25%. In order to get a better idea of what sushis are in the upper 25%, we can click and drag over the sushi points present within this area. They become highlighted in orange inside the bar chart on the left.
The next question is, which types of sushis are the most oily? So to answer this question, we can go to the categorical bar charts that we have created. For this visualization, we can toggle between different categories and compare against different bar chart variables. So to answer the question, we can select oiliness as the bar chart variable. And on this visualization, we can see that the most oiliness sorted by value is the vegetables.
Our second visualization is a circle packing diagram that shows the sushi name, its minor group, and its major group in a hierarchical diagram. Here's a question one might answer using this diagram.
I'm kosher and I cannot eat pork or shellfish. What are my options for sushi? We can answer this through a circle packing visualization. As we can see, on the left is the seafood category and on the right is the non-seafood category. So a kosher person might look at the non-seafood category first, and they'll see that they have a lot of options: egg, vegetables, and non-fish meat. They might look at vegetables and see that there's inari, sarada, nasu, and a lot more that they can choose.
Our final visualization gives more information about the people who responded to the sushi survey. This visualization includes a heat map of the geography of Japan and also an age distribution of the respondents. I'm traveling to Fukushima. Is this prefecture well represented in the data? In order to answer this question, we can find Fukushima and look at the number of respondents in that prefecture. Clicking on Fukushima, we can see the distribution for ages in that area. As we can see, it's fairly similar to the distribution for the entire country. We know that we are getting a good distribution of ages, but we also know that only 48 people from Fukushima responded to this survey. Our final question is, are older people better represented in urban or rural areas? With this visualization, it's difficult to answer this question, but you can get a feel for the answer to the question by clicking around different regions and seeing if there's a larger group of older people responding in more populous regions. This concludes our demo. Thank you so much for your time watching.